Uh, Good evening. This is Viceroy Bisabe, and our project is about flight ticket model prediction. So, briefly, introduction. One of the most sophisticated industries right now that are using dynamic pricing, whereby what I'm meaning is that the prices are never the same. The prices are always fluctuating depending on different parameters. It's the airline industry. A ticket can never be the same amount of money. For example, like from here to Dubai, if it's 2 million right now, within the next 5 minutes, it will never be the same. And even before the next 5 minutes, it was never the same. So the prices are always fluctuating. So other people tend to buy tickets highly, others tend to buy them cheaply. So our problem background is that these industries, they tend to use dynamic prices in order to cater for their revenues. For example, if it's a winter season, very few people will be traveling, so the airline industries won't be making a lot of profits. But if it's around the summer seasons, whereby the whites they go for holidays, they're on vacations, then even Africans they may tend to go to the European states to have vacations. So the air industries at that time they're making a lot of money. But a person can never know if the ticket is cheap or it's expensive. People just go and book their tickets, whatever amount of money they find there. But what if we use our linear regression model to alert these people and briefly explain to them that at a future point, like in 3 days' time, the ticket right now that it's ranging from 5 million to 6 million. Within the next 2 months, it will be around 1 million. And briefly, our problem statement: flight ticket prices are hard to guess. Today's price for a specific journey can never be the same. Just like I briefly explained in the introduction. So our main objective is to create a model that will be able to predict these cheap flights. That is our basic objective model. And how shall we do it? We shall have to get some data, some data sets, and we already acquired some data sets from Kaggle platform. So after us getting this data, we should model it. We should plan and clean it, because these data sets we found that there are some columns and cells with missing values. So we should have to eliminate those columns, or we shall have to feed in some data in those columns. Then after cleaning, we create our prediction model using linear regression algorithm. Why we're using this algorithm? Most people have been using the bagging algorithms. They've used other algorithms. But for us, we want to use linear regression, since our variables they are independent to the other, and our variables in most cases here we are going to be ranging on the price. So we shall have to train our data sets, and we shall use some tools. We are going to use a language called Python. And we shall have to use some tools inside Python, because Python has inbuilt libraries that will help us to train our model. We shall analyze our model using matrices, or the R squared, confusing matrix, or R squared. And in Python, good enough, it has some graphs whereby it will be able to plot for us the baseline of it. And like I talked about, our data sets that we acquired from Kaggle, they are composed of the flight itself, like the flight number, the source city, the departure, the stops, the arrival time, the destination city, the class, in the economy, or in the business class, the duration of the flights, and the days left to 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 buy the tickets. Then I related work, the first one of an airline ticket price system. This these people, these gentlemen, they use the bagging regression, and for their analysis they use the R squared formula, but they never use the linear. And that is why for us we want to develop the same product but using linear regression. Since linear regression, it's easy to use and it's understandable and it arranges the work very well compared to other algorithms. For the problem market segment level air ticket, it's the same case. None of the related works we have searched use the linear regression, and most of them they were using either the bagging regression, and for their analysis tools they were using the R squared. They left out the mean squared and the confusion matrices. Now the research questions when we're developing our model: one, do airlines vary? And if they vary, what has caused them to vary? Like what are the parameters that has caused our airlines to vary? So all those we shall be using the observation whereby we shall critically analyze the trends, the flight trends in prices falling and increasing of a particular airline. Then our dataset description, it will majorly fall around Africa, since that's where our scope will be, and mostly in Uganda. Because those are the trends that we can easily and we are capable of noticing. Then our methodology, of course, we shall do some design, like I talked about the observation. We shall observe the trends. Then after observing the trends, we shall collect our data. And this data collection, we already got some data from the Kaggle platforms, whereby that data has the data sets. Then we shall clean by removing the missing values and by filling in the missing values and eliminating some columns, like because the data sets, they are huge and there are some columns that are not needful, like the ticket number. We don't need to know about the ticket number. We're only interested in the flight. We're only interested in the duration, the dates, the destination city. So some columns have to be removed. Instrumentation, here we are talking about the library, the Python library tools that we shall be using. Then we shall model our project using the linear regression algorithm. Then we shall have to test it again by using either confusion matrix or by using the R squared, whereby our model should be able to predict the cheapest flight tickets available. Now our system, though we are trying to cheat, like we are trying to cheat for people to buy the tickets cheaply, we know that companies can never make losses. No, if a business is making losses, then in the end the business should close down. So this is the dynamic pricing the airline companies use. Our goal is for the customer to buy the ticket at the lowest price, but at the same time the airlines should make their profit. So in between here, there are the internal and the external factors. The internal factors is like the number of seats left or the number of planes available. Then the external factors, it's the winter, the summer. Now, like we had a pandemic, and that pandemic, it closed down all airlines. So our systematic should favor everyone. And in conclusion, for us, we are going to be using the linear regression, but we shall use the XGBoost algorithms. Our project, though further, we shall test it on these other algorithms, the bagging algorithms, other regression algorithms, in order to see which one has the best accuracy. But majorly we are going to be using the linear regression. And these are the references, parts of the references that we use to develop our work. Thank you.